Okay, so we are four members in the team. Our mentor, Dr. Prashanta Sir, and our leader, Kushagra Maheshwari, our hardware specialist, me, Akshat Reddy, and interdisciplinary, Anirudh Tota. Kushagra realized that ROs waste two-thirds of the input water and there was shortage of water in Bengaluru. In order to solve the problem, he assembled a team. A project then began. Kushagra came up with the code for God and country, which laid the inspiration for our project. We called email Prashanta sir and he gave us permission to check out the IHS water testing lab for free. Everything there was really supportive and it was great learning experience. Prashanta sir was our mentor throughout the project. Kush got in contact with a patenting firm that was costing us 2 lakhs. We looked for alternatives and found one that only cost us 60,000. The patent would require the equation that was governing the model. The derivation was difficult, but Kushagra figured it out. Anirudh reviewed it, and we were good to go. We met up with Sir again, and he gave us some more advice and new ideas to tackle problems regarding the RO system. Our RO model was bad, and the pipes were like constantly exploding, making the Arduino and other components wet. We had to order a new one. We had to let go of a team member as they were unable to put in their full contribution due to various restraints. It was hard, but at the end of the day, Anirudh broke the news to her. We tried various valve models, but none of them worked out. We tried on and off at a millisecond level to divide water in the ratio that we wanted, but that didn't work. Other things failed too. And then we realized that we should add a screen to the display, to display the values. And this addition was not difficult in terms of physical model, and me, Akshay, who was handling all the coding bit, was able to figure it out. There were a few errors in the code that Anirudh fixed. This caused us to amend the existing complete specification draft and cost us extra money. Kushagra got scolded, but got this sorted out. Anirudh prepared all the flowcharts and diagrams of the model. And then recently, when I was working on this, we call this not any RO but the RO. And unfortunately, due to the lack of installation to the power supply, I got electrocuted a few days ago. The Masters Union held a competition and we thought we could make a business out of this. We assembled a team and participated. We lost in the voting round, but we did not let that stop the technical team. We had a burger every time we met and we worked together, loyal to that one shop. There were sleepovers, late working nights and long working days. Then we finally succeeded. We plan on taking this project to the public. Our RO allows us to have an output TDS of 250, which is extremely healthy. It also saves a lot of water depending on what region the user is and what their input water TDS is. So this is our input TDS, direct tap water, which is 231 ppm. Now we'll see what happens. Yep, it's turned on. We have a nice little display. Shows the input TDS, and as we can see here, this is where all the magic happens. Yep. Before we proceed, let's talk about the internals for a bit. This is the power supply module. This supplies for the Arduino 6 volts, and this for the main components like the relays or the SVs, and it supplies 12 volts 2 amps, all of them connected parallel to a 250 volt cable. Next, this is a discharge tab that we made. So as we all know, like this thing explodes quite often due to our very highly sophisticated experiments. So let's just say there's something wrong going on. You can just like open this and all the water goes out, which is a safe way of flushing this thing instead of just opening the pipes, which explodes all over and making these components wet and malfunction. This is an Arduino Uno. This is a relay, and everything's connected in place and glued together so that none of the wires come out. This is a TDS module that gives signals to the Arduino board. And this is the display, a small OLED display. And these are all the filters. This is the pump. Here we go, our fresh water. It kind of overflowed a bit, but yeah, we're good. So now let's test the TDS of this water.